Have you ever wondered why Mercury, the smallest planet in our solar system and the closest to the Sun, can still have ice? Named after the Roman deity Mercury, the swift-footed messenger of the gods, this planet is the innermost member of our cosmic neighborhood. It's a tiny world, just a bit larger than our moon, and it zips around the Sun faster than any other planet. That's right, Mercury is the Usain Bolt of our solar system. Its swift motion across the sky earned it its name. But don't let its size fool you. Mercury is a world of extremes, with a surface scarred by countless craters due to impacts from comets and asteroids. Despite its proximity to the Sun, it's a place of great contrasts, from blistering days to freezing nights. Indeed, Mercury is a world of extremes and is a unique planet in many respects. Despite its small size, Mercury is a planet of fascinating characteristics. Just a bit larger than Earth's moon, Mercury is the smallest planet in our solar system, with a diameter of about 4,880 kilometers. This petite planet's surface is adorned with countless craters, a testament to its many encounters with comets and asteroids, making it look remarkably similar to our moon. But the similarities don't just stop there. Mercury's proximity to the Sun, at an average distance of about 57.9 million kilometers, has a significant influence on its orbital dynamics. It takes Mercury just 88 of our Earth days to complete one full orbit around the Sun. That's a whole lot quicker than our own planet's yearly journey. Now here's where things get a bit peculiar. While it swiftly circles the Sun, Mercury's own rotation is somewhat leisurely. One full spin on its axis, what we would consider a day, lasts a staggering 59 Earth days. Yes, you heard that right. A day on Mercury is longer than its year. This slow rotation combined with its rapid orbit creates a rather unusual day-night cycle that's unlike any other planet in our solar system. But what does this mean for Mercury? Well, because of this unique dynamic, the Sun appears to move in an erratic way across the sky, sometimes even moving backwards. The Sun can also appear to pause in the sky, then change its path again. It's a cosmic ballet that's both confusing and fascinating. And it's all thanks to Mercury's unique orbital dynamics. So, despite its modest size, Mercury certainly doesn't fall short of surprises. Its heavily cratered surface, swift orbit, and peculiar day-night cycle make it a truly unique member of our solar family. Mercury's orbital dynamics and physical properties make it a planet of interest. And as we'll find out, there's even more to this tiny planet than first meets the eye. Mercury presents a dramatic range of temperatures unlike any other planet in our solar system. Being the planet closest to the Sun, it's perhaps no surprise that it experiences some of the most extreme temperatures. During the day, the Sun's rays beat down onto Mercury's surface, causing temperatures to soar to a scorching 800 degrees Fahrenheit. That's hot enough to melt lead, but don't let that fool you into thinking nights on Mercury are balmy. Quite the contrary. As the Sun sets, Mercury's temperature takes a nosedive. The lack of sunlight causes the thermometer to drop dramatically, reaching a chilly negative 290 degrees Fahrenheit. That's colder than the surface of Pluto, the most distant planet in our solar system. You might be wondering, how can a planet have such wild temperature swings? The answer lies in Mercury's extremely thin atmosphere, or rather, its exosphere. Unlike Earth's thick blanket of air that traps heat and moderates our temperatures, Mercury's exosphere is so thin it's almost non-existent. It's composed mainly of oxygen, sodium, and hydrogen, but it's too sparse to retain any of the Sun's heat. When the Sun goes down, all the accumulated heat from the day simply escapes back into space, leaving Mercury to freeze in the dark. This lack of a substantial atmosphere also means that the sky on Mercury is always black, even during the day. There's no blue sky to scatter the Sun's light, no clouds to create a sunset. It's a stark and unforgiving landscape dominated by extreme temperatures and a thin, barely there atmosphere. But as inhospitable as these conditions may seem, they're part of what makes Mercury so fascinating. Each feature of this sweltering planet, from its blistering days to its freezing nights, adds to our understanding of the diverse collection of celestial bodies that make up our solar system. The extreme temperatures and thin atmosphere of Mercury contribute to its unique planetary profile. Mercury is not just a hot, barren world. It holds magnetic mysteries and has been a subject of human exploration. Unlike its planetary neighbors Venus, Mars, and our moon, Mercury possesses a significant magnetic field. Though it's about 100 times weaker than Earth's, its existence is a fascinating anomaly. This magnetic field suggests the presence of a molten core, which is surprising for such a small planet. It's believed that the dynamo effect, driven by the planet's rotation and its molten core, is responsible for generating this magnetic field. Now let's embark on a journey of discovery. The first human-made visitor to Mercury was NASA's Mariner 10. Launched in the mid-70s, it conducted multiple flybys, mapping about half of the planet's surface. It was Mariner 10 that first detected Mercury's magnetic field, a discovery that puzzled scientists and sparked further curiosity about this small, innermost planet. Fast forward to the 21st century, the baton of exploration was passed on to NASA's Messenger spacecraft. Launched in 2004, Messenger became the first spacecraft to orbit Mercury in 2011. Over 4 years, it diligently mapped 100% of Mercury's surface and made several significant discoveries. These include evidence of water ice at Mercury's poles, a finding that turned heads in the scientific community. These missions, Mariner 10 and Messenger, have provided us with a wealth of data about Mercury. They've helped us understand the planet's magnetic field, its geological history, and its surface composition. And they've raised new questions, fueling the drive for future exploration. As we strive to unlock the secrets of our solar system, Mercury, with its magnetic field and the data from exploration missions, remains a world of interest. Every bit of information we glean takes us a step closer to understanding the intricacies of our cosmic neighborhood. Mercury's magnetic field and the data from exploration missions have given us valuable information about this small planet. Mercury holds keys to some of the mysteries of our solar system. It is more than just a tiny, sweltering planet close to the sun. It's a scientific trove, offering profound insights into the formation and evolution of terrestrial planets. Mercury's unique characteristics are a rich source for study. For instance, it has a dense metal core that occupies about 85% of its volume. This is an unusually large proportion compared to other terrestrial planets. This feature triggers a tantalizing question: how did Mercury end up with such a high ratio of metal to rock? The answer could reshape our understanding of how planets form and differentiate into a core, mantle, and crust. Some theories suggest that Mercury may have formed from the solar nebula's metal-rich material, closer to the Sun. Others propose a catastrophic event, such as a giant impact that stripped away much of the original crust and mantle, leaving the planet with a large core. The study of Mercury's core also sheds light on another intriguing feature: its magnetic field. Despite its slow rotation, Mercury has a global magnetic field, which is likely generated by a dynamo process in its molten outer core, much like Earth's. Understanding the dynamo mechanism in Mercury's core could provide valuable insights into the magnetic fields of other celestial bodies, including Earth. And then there's the astonishing discovery of water ice on Mercury. Yes, you heard it right, water ice on the planet closest to the Sun. The Messenger spacecraft found evidence of water ice in permanently shadowed regions at Mercury's poles. This discovery suggests that even the hottest planet in our solar system holds clues to the presence of this essential compound. It opens up a new avenue of research about how water and other volatile substances are delivered to the inner planets. The scientific significance of Mercury and its recent discoveries continue to intrigue and challenge our understanding of planetary science. As we delve deeper into the mysteries of the innermost planet, we can expect to uncover more secrets about the workings of our solar system. Mercury, often overlooked, is a treasure trove of information. This petite planet, just a tad larger than our moon, whirls around the sun in a swift 88 Earth days, yet takes 59 of our days to rotate just once on its axis. Its proximity to the sun exposes it to scorching daytime temperatures, while its nights are bitterly cold due to its exosphere's inability to retain heat. Despite its harsh climate, Mercury has a magnetic field, albeit 100 times weaker than ours. And against all odds, it even harbors water ice in its shadowed polar regions. These fascinating attributes, along with its dense metal core occupying 85% of its volume, make it a compelling subject for scientific exploration. Mercury's unique characteristics and the discoveries made by orbiting spacecraft continue to intrigue and challenge our understanding of planetary science. As we continue to explore Mercury, we look forward to unearthing more secrets about this sweltering yet ice-bearing innermost planet of our solar system.